Next example of subspace. Let V is equal to R3. Obviously, this V is equal to R3 is a vector space with respect to usual addition and usual scalar multiplication, like this. Right here, this word that V is equal to R3 be a vector space with usual addition and usual scalar multiplication. And W is the subset of V. The W is the set XYZ, three tuple from V belongs to V or belongs to R3, such that 2x plus 3y plus 4z is equal to 1. If we observe the last example, this is 2x plus 3y plus 4z is equal to 0. And if W is the set, then W is what? Subspace of this R3 or V. In the last example, we have seen that this W is a subspace of V under this condition, 2x plus 3y plus 4z is equal to 0. But if this 2x plus 3y plus 4z is equal to 1, then what happens? The question is determine whether W is subspace of V, Y. So W is not subspace. Actually, W is non-empty and W is subset of V. So directly write this sentence directly that W is not equal to phi, W is non-empty, and W is subset of V, obviously, because the elements in W comes from V. That is, it is a subset of V. And we have the two element x, y, z, such that this condition is satisfied by that element. So we have many elements having this condition. So W is not equal to phi and W is subset of V. Okay. Next condition, we have to check whether this W satisfies the remaining two conditions of subspace. So what are the two conditions? The addition of two elements of W belongs to W. This is the first condition. Addition of every two elements of W belongs to W. And the second condition, any scalar, that is the element of R, real number, and any element of W, its scalar multiplication belongs to W. If these two conditions are satisfied by W, like this, that is the addition of every two elements belongs to W, and the second condition is any element of W and any scalar, if their multiplication, that is Ku bar, belongs to W, then we say that W is a subspace. Otherwise, if one of them condition is fails for W, then W is not subspace of V. So we have to check whether these two conditions are satisfied by elements of W or not satisfied by elements of W. So first condition, now we take two elements, suppose U bar is x1, y1, z1 and V bar as x2, y2, z2 belongs to W be any two elements. And therefore we have that this x1, y1, z1 belongs to W, therefore it satisfies this condition that 2x1 plus 3y1 plus 4z1 is equal to 1. Also x2, y2, z2 is the element of W, means it satisfies this condition that 2x x2 plus 3y2 plus 4z2 is equal to 1. Suppose equation number 1 and 2. Now what is U bar plus V bar? That is x1, y1, z1 plus x2, y2, z2. So add these two elements by usual addition. What is the definition? Usual addition. So x1 plus x2, comma, y1 plus y2, comma, z1 plus z2. This is the addition. Again, three tuple. Now we have to verify whether this U bar plus V bar belongs to W or does not belong to W. So when this U bar plus V bar belongs to W, if 2 into x1 plus x2 plus 3 into y1 plus y2 plus 4 into z1 plus z2 is equal to 1, then this element belongs to W. So consider 2 into x1 plus x2 plus 3 into y1 plus y2 plus 4 z1 plus z2. And then multiply by 2, multiply by 3, and multiply by 4 in bracket. And then collect the terms 2x1, 3y1 plus 3y1 plus 4z1 in one bracket, and then plus sign 2x2 plus 3xy2 plus 4z2 in another bracket. And the value of this bracket is 1 by using this equation number 1, and this is equal to 1. And 1 plus 1 is 2, not equal to 1. And therefore, U bar plus V bar does not belong to W, because when U bar plus V bar belongs to W, if 2x1 plus x2 plus 3y1 plus y2 plus 4z1 plus z2 value of this quantity is equal to 1. But it is not equal to 1. It is equal to 2. It is not equal to 1. And therefore, U bar plus V bar does not belong to W. And therefore, we cannot say that this W is, then what we have, therefore, U bar plus V bar belongs to W is not true for all U bar and V bar belongs to W. And therefore, W is not subspace of V. That is, W is not closed for addition. Addition of each two element of W not necessarily belong to W, and therefore W is not subspace of V. And we can give this answer of this problem by using counter example. That is why to show W is not a subspace, and that is this condition that addition of two element of W not necessarily element of W. We can prove this or this condition by using counter example. So we take two elements U bar as -1, 1, 0, and V bar as -3, 1, 1 belongs to W. Be any two elements. Why these are the element of W? So we have to take the two elements. We have to give the counter example. It means we have to show that the addition of two element of W is not element of W. Okay. So first take two elements from W. These are the element from W. -1, 1, 0. Why? Because this satisfies this condition. 2 into -1 plus 3 into 1 plus 4 into 0 is equal to 1. 2 into -1 is -2. 3 into 1 is +3. -2 plus 3. 4 into 0 is 0. So -3 plus 4 plus 0 is what? Is 1. So this -1, 1, 0 is the element of W. Then -3, 1, 1. This is also the element of W. Why? Because 2 into -3 is -6. 3 into 1 is +3. And 4 into 1 is +4. So -6 plus 7 is again 1. So -3, 1, 1 satisfies this condition that 2x1 plus 3y1 plus 4z1 is equal to 1. So these two are the element of W. That you need two elements from W randomly. So why this element belongs to W? Because it satisfies the condition 4 into -3, 2 into -3 plus 3 into plus 1 plus 4 into 1 is equal to 1. Also this is the element of W. Why? Because 2 into -1 plus 3 into 1 plus 4 into 0 is 1. Now, what is the addition of U bar and V bar? So U bar is -1, 1, 0 plus V bar is this -3, 1, 1. And so addition is -4 plus 1 plus 1. And this is not the element of W because 2, it does not satisfy this condition. 2 into -4 plus 3 into 2 plus 4 into 1 is what? -8 plus 6 plus 4 is 2. It is not equal to 1. And therefore -2, 4, 1 does not belong to W. And therefore U bar plus V bar belongs to W. For all U bar and V bar belongs to W is not good. This condition is not true for W. That U bar plus V bar belongs to W. For all U bar and V bar belongs to W. This condition is not true for W. And therefore W is not subspace of V. So we can give the proof of this condition that addition of two elements of W does not belong to W like this or like this. That is by using counter example. And the second condition also is not satisfied for this set. We can also give the answer of this problem like this. That is, take U bar as -1, 1, 0 belongs to W as the element of W -1, 1, 0. And take K U bar, take K scalar as 5. So 5 into -1 into 1 is this. And as this element is not element of W, -5, 5, 0. Because 2 into -5 plus 3 into 5 plus 4 into 0 is what? -10 plus 15 plus 0 is 5, is not equal to 1. And therefore this element, this condition is not satisfied. That any scalar and any element of W, its multiplication belongs to W. Or we can also prove that 0, 0 element does not belong to W, because what is the 0, 0 element of this R3 W is U bar is equal to 0, 0, 0. And what is the condition? 2 into 0 plus 3 into 0 plus 4 into 0 is 0 is not equal to 1. Therefore, 0 vector does not belong to W, and therefore W is not subspace of V. Because we know that when W is subspace of V, if W is itself a vector space, and when W is itself a vector space, if W satisfies 10 properties, that is this is the property number A3. So 0 vector must exist in that W, but 0 vector does not belong to W. And so we can give the answer here, the answer of the problem. This is the first method up to this. This is the first method. This is second method. By using counter example, we show that U bar plus V bar belongs to W. For all U bar and V bar belongs to W. This condition is not true for W. This is the third, that K U bar belongs to W for all U bar belongs to W, and for any scalar K, this is not true. We can give the counter example. And also we can show that this is the fourth way, that zero vector does not exist in W, zero vector does not belong to W, and therefore W is not subspace. So we can give the answer of this problem in different way. So here the problem is this, that if 2x plus 3y plus 4z is equal to 0, then the set W is subspace of V, but it is equal to 1. 2x plus 3y plus 4z is equal to 1 or is equal to 2 or is equal to 3 is equal to minus 1 other than 0. If there is another number other than 0, suppose there is 1 or minus 1 or 2 at this place, then it is not subspace. So if it is equal to 0, in the place of 2, 3, 4, there are another element. Suppose all these 2, 3, 4 are equal to 1. That is x plus y plus z is equal to 0 is the condition. Then also W is subspace of R3. But if the is equal to 0, in the place of is equal to 0, it is non-zero element, either negative or positive, any non-zero element, then it is not subspace of V. So remember these things, that is equal to. And in the place of 2 and 3 and 4, we have any another number. That is, take arbitrary as ABC. Suppose that V is equal to R3, W is the set of x, y, z belongs to V or R3, such that ax plus by plus cz is equal to 0, where ABC are any real number, maybe positive, maybe negative, all are equal, all are different, then show that W is subspace of V. So instead of this 2, 3, 4, if we take any real number A, B, C, then also, but is equal to 0. Remember that is equal to 0. Then also the set W is a subspace of R3. So in the place of x, y, z, if you take in the coefficient of x, y, z are equal to 1, then x plus y plus z is equal to 0. This is also the subspace of R3. So this is the general example, generalization of that example, that V is equal to R3 and W is set x, y, z belongs to V, such that x plus by plus cz is equal to 0, where A, B, C are belongs to R, means any real number, then show that W is subspace of V. So this is the generalization of this example. So in order to answer, we just write 2, 3, 4 by ABC in this example. So we get the answer of this problem. Just write 2, 3 and 4 as ABC. So first condition, write directly that clearly or obviously W is non-empty and W is subset of V. Now we have to show the two conditions. Let U bar as x1, y1, z1 and V bar as x2, y2, z2 belongs to V arbitrary element. And these U x1, y1, z1 is the element of W, means it satisfies this condition that ax1 plus by1 plus cz1 is equal to 0, equation number 1. Also this x2, y2, z2 is the element of W. So we have ax2 plus by2 plus cz2 is equal to 1 by using this condition. And then now what is U bar plus V bar? Addition of these two elements x1, y1, z1 plus x2, y2, z2 is what? x1 plus x2, comma, y1 plus y2, comma, z1 plus z2, usual addition. And now we have to show this is the element of W. So consider A into x1 plus x2 plus b into y1 plus y2 plus c into z1 plus z2, and it is equal to 0. If this is equal to 0, then we say that x1 plus x2, comma, y1 plus y2, comma, z1 plus z2 belongs to W. So consider A in bracket x1 plus x2 plus b in bracket y1 plus y2 plus c in bracket z1 plus z2, and it is ax1 plus ax2, right, multiplied by a, b, c in bracket, and then collect the terms ax1 plus by1 plus cz1 in one bracket, and then ax2 plus by2 plus cz2 in another bracket. And the value of this ax1 plus by1 plus cz1 is 0 by using 1. And the value of ax2 plus by2 plus cz2 is 0 again by using equation number 2. So 0 plus 0 is equal to 0. And therefore U bar plus V bar belongs to W, because it satisfies the condition. And therefore we say that U bar plus V bar belongs to W for all U bar and V bar belongs to W. Because these U bar and V bar are any two elements of W, arbitrary element of W, and the condition satisfied for arbitrary element, therefore the condition is satisfied for all elements. So we say the condition is satisfied for all elements. Then next condition, take one element of W, suppose x, y, z as the element of W and k be any scalar. Now we have to show k into U bar belongs to W, k be any scalar. Then as the x, y, z belongs to W, we have Ax plus By plus Cz is equal to 0. Suppose equation number 1. Because this x, y, z is the element of W means it satisfies the condition. Then consider k into u bar is k x y z is equal to kx comma ky comma kz. This is by using the definition of scalar multiplication. And then now we have to show this kx1 comma ky1 comma kz1 belong, not z1, kx comma ky comma kz. We have to show this kx ky kz, this element belongs to W. When this element belongs to W, exists in present in W, if it satisfies the condition, that is a into kx plus b into ky plus c into kz is equal to 0. So consider a into kx plus b into ky plus c into c into kz. Either write x1, y1, z1 as the element of W. So right here x1, y1, z1. Suppose then we have ax1 plus by1 plus cz1 is equal to 0. So write ku bar as k x1, y1, z1 as kx1 comma ky1 comma kz1. So then consider a kx1 right here x1 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 all suffix are 1. Either take u bar as xyz or x1 y1 z1. So we consider ax1 akx1 plus bky1 plus ckz1. So take k common, we have x1 plus by1 plus cz1 and it is equal to 0. And so k into 0 is 0. And therefore we say k u bar belongs to W for all u bar belongs to W and for any scalar k. Because it satisfies, this k u bar satisfies the given condition of W. And hence W is subspace of V. Because W satisfies the two conditions. W is non-empty, W is subset, and W satisfies these two conditions of subspace, and therefore W is a subspace of vector space V is equal to R. So this is the generalization of the previous example. Next example, V is equal to R2. W is the set xy belongs to R2 such that x square minus y square is 0. Determine whether W is subspace of V. So we have to show whether, we have to determine whether this W is subspace of V. So when W is subspace of V, if W satisfies the two conditions, that is the addition of element of W, any two element addition of any two element of W belongs to W, and any scalar and any element of W, its multiplication belongs to W. If one of them condition fails for W, then W is not subspace of V. So if, in order to show if W is not subspace of V, we have to give the counter example for either condition number 1 or condition number 2. So here the take u bar as 4, 4. Why this element 4, 4 belongs to W? Because 4 square minus 4 square is 16 minus 16 is 0. Also the element 3 and minus 3 belongs to W. Take as V bar. And why this element 3 minus 3 belongs to W? Because it satisfies this condition, x square minus y square is equal to 0. 3 square minus 3 square. So 3 square is 9 and minus 3 square is also 9 and 9 minus 9 is 0. So these two are the element of W. And then what is addition of u bar and v bar? Is 4, 4 plus 3 minus 3. And the addition is 7 and 1. 7 and 1. And this is not element of W. Because 7 square minus 1 square is not equal to 0. Okay. And therefore addition, these 4, 4 and 3, 3 minus 3 are the element of W, but their addition does not belong to W, and therefore u bar plus v bar belongs to W. For all u bar and v bar belongs to W is not true for all u bar and v bar belongs to W. It may be true for this condition, may be true for some element. If you take u bar as 4, 4 and v bar as 3, 3, these are the element of W. Then u bar plus v bar is what? 7, 7, and 7, 7 is the element of W. So we have to pick up or take the example, we have to take the values of u bar and v bar such that u bar and v bar are the element of W, but their addition does not belong to W. Now we have to find the counter example. So this is the counter example. So don't take as u bar as 4, 4 and v bar as 3, 3. Or don't take u bar as 4, 4 and v bar as minus 3, minus 3. If you take u bar as 4, 4 and v bar as minus 3, minus 3, then their addition is what? 1, 1. And 1, 1 is the element of W. So we have to take the element of W in a such a way that They are element of W. U bar and V bar are element of W, but their addition is not the element of W. And this is the example of counter example. So next example is again of the type V is equal to R3. W is what? Is the set of 3 tuple X, Y, Z belongs to R3, some element of R3 such that X is 0 or Y is 0. So what are the element of W? Either X coordinate is 0 or Y coordinate is 0. For example, what are the element of W? 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 3. These are the elements. Or take X as 0 or 0, 4, 5. These are the element of W. If X and Y both are 0, Z is non-zero or 0, then also it is the element of R3. X is 0 or Y is 0 means what? Either X is 0 or Y is 0 or both are 0. So for example, 0, 0, 4 is also the element of W. 3, 0, 5 is the element of W. So these U bar and V bar are the element of W. But what is their addition? What is their addition? It is the element 0, 0, 0, 4 plus 3, 0, 5 is 3, 0, 9. And this is the element of W. Means this is not the counter example of W. And for this, from this example, we cannot say that the addition of every two element of W is the element of W. This is true for these two elements, and then we cannot say it is true for all elements. For example, we take this element, this set, this element, U bar as 0, 1, 4 and V bar as 3, 0, 5. These are the element of W because in this place, in this U bar, X coordinate is 0. In this V bar, Y coordinate is 0. Is one of them must be 0. So these two are the element of W. But what is their addition? 0 plus 3 is 3, 1 plus 0 is 1, and 4 plus 5 is 9. And this is not the element of W, and therefore W is not close for addition. That is, the addition of every two element of W does not belongs to W, and therefore W is not subspace of it. So don't write this example, write this example as a counter example. So this is the counter example. Don't write this as it is for justification that how we can write the counter example. So we have to take two elements from W such that their addition does not belong to W, and therefore the condition first fails. Or we have to give the counter example for the condition number 2, that is the some element of W and some scalar K, their multiplication does not belong to W. For example, this example, if we consider this example as the 2x plus 3y plus 4z is equal to 1. So this is the answer. This is the counter example for addition. In some example, both the condition fails. That is, the addition of two elements of W does not belong to W is also fails, and this condition also fails. That is the some element of W and some scalar, their multiplication does not belong to W. So in this example, both the conditions are failed. So we have to write a counter example for any one condition, right? Either this example or like this example as a counter example, right? U bar as minus 1, 1, 0 and K U bar, K take K as 5. So 5 into minus 1, 1, 0 is minus 5, 5, 0. And this is not element of W because it does not satisfy this condition. Okay. And therefore we can say that W is not subspace of V. So in some example, both the condition fails. In some example, only first condition fails. For example, in this example, the second condition is true for W, that any scalar and any element of W, its multiplication belongs to W. Because if you take this element, suppose V bar as 305 and K as a scalar 5, then what is 5 into 305 is 15, 0, 25. That is, we have k into 0 is 0, 5 into 0 is 0. So the second condition is true for this W, but the first condition fails, that the addition of every two elements of W does not belong to W. And therefore, we have to write the counter example for the failed condition. That is, either the condition number 1 fails for the example, or the second fails for the example, or both. In some example, both the condition fails for the example for set. So we have to write counter example for the condition which fails for that subset. Okay. So we will see the next example of subspace in the next lecture.